Okay then, so so this is an example of compiling an MPI code, Fortran-based, and on an interactive session on Lotus, and then submitting as a batch job to Slurm. So I'm just going through the tasks. I think that the second task, you are now familiar about how to invoke the session on Lotus. In this case, we require n task of 2, so 2 calls, but feel free to use any number to compile and test interactively your code. Make sure that the module environments are loaded. And just to mention here, when you are testing interactively your code, you have to specify the number of core you're testing, because it's not, this is not a batch job, because when you do a batch job, you specify n tasks. So Slurm will allocate those cores to the executable. When you're doing interactively, use the same command MPI run, which is used with, which uses specific routes to access the storage. So please don't use MPI exec. We recommend MPI run all the time. And then when you are on the interactive session, just be aware that interactive session lasts to the default time, which is 1 hour. So if you have a large code that you're trying to compile and test, make sure when you request the interactive session here, maybe add the flag the time if it's more than 1 hour. Otherwise, you lose your session. It just get killed by Slurm due to timeouts. We provided scripts as batch here, so I'm just going to go through it and just demonstrate a few things on the terminal here, because I didn't put too much into this cheat sheet, so I'll better demonstrate it here. So the first demonstration is I have, I've got 2 terminal on the same, doesn't have to be necessarily on the same time machine, but just happen to have on the same time machine for this demo. I've got all my module loaded here. And then I'll check the job scripts as it, so it's already compiled. Just gonna have a look to the, so the job script here has, I've commented 2 directives, which are the constraints and the node for you to edit it yourself if you want to change from the default ones. And so here, the directive that we have, you're all familiar with the time, the memory. We have added n task, which is the number of MPI ranks we get spawned at runtime. So if you want to run this job with 4, 6, 2, so this is the variable that needs to be specified. If it's not specified, it will default to 1. So we end up running a serial, well, a parallel code that run on 1 core. The nodes variable here, which is commented out, initially it wasn't specified. So I'm just going to show a demo how Slurm allocate the nodes. So if the nodes is not specified, where this full code gonna end up? Are they going to end up on the same node, or are they going to be distributed? This is really dependent on the what's available. So you cannot tell until the job is scheduled. But if you want to specifically want the job to run across 2 nodes or on a single node, the node variable here has to be specified. So let me just do a quick example here. If I run some on exercise, if I just submit this job right now, I'm on the blue terminal here, or I can go to the yellow box or SBatch, and I just put the job script file. And I'll just check shouldn't take long. I'm training 049. Oh, did run. Let's check on how many nodes the job got allocated. So I'm gonna just use the Slurm command SACCT, because all the information about the job are kept in a database, and the SACCT allows you to retrieve all the data on terms of usage, time, resources being used of the job. So I need to specify the job ID, so it was 647. And I want to specify a format. So I'm interested into state, did it complete, which node has been used, and how many calls. Right, so the output here telling me, so it's completed, used one node, and the 4 calls were all in one node. Now let me change this. Instead of submitting the bash script as it is, I'm going to enforce some changes at submission time, which is going to override whatever is specified in the batch in the job script file. So I'm going to put minus. I can do either nodes. I'm going to use 2 nodes. And I'm going to change as well the number of tasks. Put it to 6. Okay, this is pending. It didn't run instantly. It is pending because it's going to take some time to find those, how many nodes, 2 nodes, and each node has to have a number of calls. It depends. It's going to if it has 3, it's going to split it between the 2 nodes. Maybe it's just going to put 1 call, 1 rank on one node, and 5 on others. So it's gonna Slurm. We're gonna negotiate and look at this, and it did run now. So let's check how it did run. Job got a hand. 6, 7, 8. And CPUs. Yeah. Okay, perfect. A good split. No, yeah, I think it did. There is a failure here for some reason. I need to find out why. It could be. Let me try another. I don't know why it failed on node 4. Right.
Joys of live demoing, eh, Fatima?
Yeah. So
just a quick time reminder. So it's 2:10, so I think we were hoping to do Ag's demo soon-ish,
okay, so I'm just
to make sure that we
this.
finish on time.
So the message here that you can override the setting of the job script by passing them as an argument directly to the command line. The resources here, one important thing is the maximum memory and the maximum required memory. So that is possible to retrieve. If I go back to the previous job I ran, was this job. I can just show you this. So it's spec and max access. So this tells me that I've requested 100 megabytes, and this is the maximum has been used. So in case 100 is quite a lot, and I should estimate my request less than 100, and then that would improve the waiting time for the job. This is just a quick, what are the parameters that you need to look at in terms of pending time improvement, and also the task that you're running, how many tasks and how you allocate the resources. So I'm just going to stop at here and pass it on to Ag for the last session, which is the tutorial. Let me just stop sharing.
Thanks, Fatima.